This is going to be the last video for week 8, and it's going to be rather short too. Alright, so we've discussed the grand definition finally. And now we just want to follow up on some things. So first, I want to ask you a question. When is a function differentiable? I want you to pause the video and see if you can give me a good response. Alright, well, you probably said a few different things. One thing is you probably said, well, the short answer is just going to be, well, you have to make sure that you check that it satisfies the limit definition. The grand theorem, or the grand definition, or any of the other ones if you're working in with different number of inputs and outputs. Okay. Really, the long answer is that there are tests for differentiability. Okay, a couple of them we're gonna see here, but some of them we're not gonna talk about. Okay. All right, and one of those things that we can test is we can look at the partial derivatives. Okay, so if we have a vector valued function, we can look at all the partial derivatives. We need to make sure of two things. One, they have to exist, right? And I'll erase that. They have to exist, and second, we have to prove that they're continuous, or at least, say, be able to justify why they're continuous at our point of interest. And if we satisfy those criteria, then we can conclude differentiability. Okay? Just be careful and note that this is not if and only if, right? And in fact, the converse, if you look at the converse, you run into issues. Okay? And maybe a few of you might see something in this in the project. Okay. All right. So that's one thing. That's one test that we can do. Okay. Another thing that we get as a result here is that, and this is more just like a duh thing. Like we say a function, or we say the vector value function is differentiable at a point if and only if each of the components is differentiable. And that's the kind of, well, like, really, are you, like, we're actually spending paper on this? Yeah, well, we do have to make sure that we have that important remark in here. Okay, and then the last one is, and this is also kind of like a really Professor Bright thing, is that we still have the extension from single variable calculus where we said, okay, well, if we have differentiability, that implies continuity. Okay, so that's great, but we wanted to be able to prove differentiability, right? Well, maybe the contrapositive will help us, right? The contrapositive would be that if it is not continuous, then it is not differentiable. Okay, so this is a nice theorem to use when you're checking for differentiability. Is if you can clearly see that it's not continuous, well, then it's not going to be differentiable. But it doesn't help you prove differentiability if you do need to show that. Okay, so just keep that in mind. And that's going to be the end of this video, and that's going to conclude week 8. So let's have fun with derivatives in class.